In the last class, we have discussed with the two terms. One is the principle of reversibility of the light, and the second one is lateral displacement. So, principle of reversibility of light, that is the reflected ray or the refracted ray is reversed, they retraces their original path, and also the lateral displacement we have discussed. That is the definition of lateral displacement is the perpendicular distance between the original path of the incident ray and the emergent ray is called lateral displacement. So now emergent ray. So emergent ray is that when the ray of light comes out from the glass slab. Okay, now first of all, what has happened there? The ray of light is passing from radial medium towards the denser medium, air to glass. Refraction takes place, and therefore the bending of light will take place closer to the normal. Please follow the diagram which I explained in the previous class. So the refracted ray will bend closer to the normal. Then again the second refraction takes place because the ray of light has to come out from the glass slab towards the air. So again the second refraction takes place, and that refracted ray will come out from the glass slab and it comes towards the air. So that refracted ray, when it comes from the glass slab towards the air, the refracted ray will known as the emergent ray. So we have discussed about the emergent ray, okay, about the lateral displacement and the principle of reversibility of the light. Now today we will discuss only the factors affecting the lateral displacement. So there are four factors in which the lateral displacement it depends. Number one factor is thickness of a glass slab. Second one is the angle of incidence. Then third one is the refractive index of the glass slab, and fourth one is wavelength of the incident light. Now the first one, the refractive index is directly proportional. The lateral displacement is directly proportional to the thickness of glass slab. That means lateral displacement is directly proportional to the thickness of the glass slab. So that means let us consider this is the glass slab, okay, and more the thickness of the glass slab, more will be the lateral displacement. More the thickness of the glass slab, more will be the lateral displacement. So how it happens is that now let us consider a glass slab, okay, and the thickness of the glass slab is more. Now this is the normal, this is the incident ray, and this is refracted ray. Then again this is normal, then again this one is refracted ray. Okay, this is two are refracted ray. That means AO is the incident ray, OD is the refracted ray, and OC is the emergent ray. And when you produce the length of this, increase the length of this incident ray, and this distance we call it as lateral displacement. Okay. Now this lateral displacement will become more. That means this length will become more. It expands, it goes, it increases. So depending upon the thickness of the glass slab. So when the thickness of the glass slab is more, the lateral displacement will be more. Or when the thickness of the glass slab is less, lateral displacement will be less, which we call it as a vice versa. Okay. So the first factor in which the lateral displacement depends is thickness of glass slab, which means that more the thickness of the glass slab, more will be the lateral displacement, and vice versa. Second one is angle of incidence. That means angle of incidence is this one. Okay, this is angle of incidence. More the angle of incidence, when you are increasing the angle, okay, when you increase the incident ray get increased. Suppose if the incident ray will come here, so the angle of incidence will go on increasing. So more the angle of incidence, more will be the lateral displacement. How it happens is, when this will increase, look at it. That means here, this side. So I will increase the incident ray. So when the incident ray increases, angle of incidence will also increase. And when I draw the original path of the incident ray, so what will happen is that, so this path will increase. That means this line will increase here. So therefore, we can say that lateral displacement increases with the increase in angle of incidence, or lateral displacement decreases with the decrease of angle of incidence. So therefore, in these two factors, lateral displacement is directly proportional to the glass slab. Lateral displacement is directly proportional to the angle of incidence. More the angle of incidence, more will be the lateral displacement. Lesser the angle of incidence, lesser will be the lateral displacement. Third one is refractive index of the glass slab. That means lateral displacement is again directly proportional to the refractive index of the glass slab. So more the refractive index of the glass slab, more will be the lateral displacement. Okay, more the refractive index of the glass slab, more will be the lateral displacement. Lesser the refractive index of the glass slab, lesser will be the lateral displacement. And fourth one is lateral displacement is inversely proportional. Here it is inversely proportional. In three cases here, lateral displacement is directly proportional, which means if the thickness of glass slab increases, lateral displacement increases. If the thickness of glass slab decreases, lateral displacement decreases. Likewise, if the angle of incidence increases, lateral displacement increases. If the angle of incidence decreases, lateral displacement decreases. Here also, if the refractive index is more, lateral displacement will be more. If the refractive index is less, lateral displacement is less. But in the last factor here, lateral displacement is inversely proportional to the wavelength of the incident light. That means the wavelength incident light is this one. So that means if the wavelength of incident light is more, lateral displacement will be less. Okay? So it is inversely proportional. Inversely proportional means what happens here? If the wavelength of incident light means the light coming from the source when it falls on the glass slab. So when the wavelength of that incident light is more, then lateral displacement will be less. If the wavelength of incident light is more, lateral displacement is less. Similarly, if the wavelength of incident light is less, lateral displacement will be more. So therefore, these are the four factors in which the lateral displacement it depends. So in the next class, we'll come to the next portion of the chapter, refraction. We'll come to the refraction through prism.